Yeah, today I want to talk about my doubts and confusion over scientific fundamental beliefs. And this is because I'm now trying to explain how the Earth works to my son. And I'm having difficulty in connecting together the explanations in the book with my memory of science. And I thought I'd share these doubts with you. And number one doubt is over the beginning of the universe and the Big Bang theory. Because when I look at a Big Bang, like a firework or some other explosion, you have a central hotspot and all of the bits fly out from that central hotspot. They fly out radially like a bicycle wheel and the spokes of a wheel. But when I look at the evidence about the galaxies in the universe, they are all moving, that's true. But they're all moving in random directions. And so the idea they all started at a single point doesn't make sense. And also they're accelerating, which also doesn't make sense because after a Big Bang, the force acting stops after the explosion and things should be slowing down. So the Big Bang doesn't make sense purely based on observation, but also on logic. You know, the idea that all the matter in the universe came together at a single point also makes no sense, because the idea of pushing things together is very difficult. You take a piece of paper and you fold it 7 or 8 times, and that's it. You can't fold it anymore, even with a lot of force. So the idea that all the matter in the universe is capable of getting near each other and at the same moment is just unthinkable. And I can't see any experiments which have been done to demonstrate this as plausible, let alone possible. And so the whole Big Bang theory doesn't seem to make sense to me. And the second big scientific doubt I have is related to evolution, because the idea that we are told is that we started as single cell molecules or whatever, viruses, I don't know, the very simplest cell, and that was an accident caused by some kind of electrical discharge into the primordial soup that existed on Earth millions of years ago. Well, that may or may not be true, but what happened afterwards doesn't make sense, because the idea that survival of the species and that the mutation of these single cells into something more sophisticated, which then had a reproductive advantage over the other single cell items, makes no sense. And when you look at evolution all the way through to humans, then you think, well, this just would be so many random mutations. This would require so much impossible things happening, so many impossible things happening, that it's almost unbelievable. And the way science works is you come up with a hypothesis and then you test it. And so let's look around the planet as it is now and see if it's feasible that humans evolve from these single cell items. Well, one of the reasons this is not true is because these items, these living organisms, still exist. And all the so-called ancestors of humans still exist. And if there was a superiority of humans over even, I don't know, monkeys, we would have wiped out all of the previous species. It would have taken over. And it hasn't. We all coexist, and all the simpler life forms are still here. So the idea that a single mutation became the dominant species doesn't match the evidence I see around me. The other problem with evolution is that while we can see evolution happening in a small way in the animals and life forms around us, so for example, if the habitat changes, then the red squirrel could be replaced by a brown squirrel, for example, or if the snow melts, then being white has a serious disadvantage against the green background, and so the white animal would die out and be replaced by a green one. But that's not creating a new species, that's simply changing details of the existing species. And that must be true. You look at evolution in humans, and even if we had common ancestors originally, then we are all almost identical, but we have local variations based on evolution giving an advantage to some of these variations in some parts of the world. And so we see variations, small variations in humans as you travel around the world, which you can explain by local environmental conditions. So that's not creating a new species. We're all still humans. So I doubt the whole principle of evolution from the beginning. And then we come on to the big one today, which is climate change. Now, given that I doubt scientists on the beginning of the universe with the Big Bang Theory, and I doubt scientists over evolution, of course I now doubt them on climate change. So let's look at the evidence. Okay, so first of all, they say the planet is getting warmer. Well, what does that even mean? How do we know the temperature of the planet? It's not like a human where you put a thermometer in the mouth and you can get a temperature reading. So how they actually measure the temperature is confusing. But let's say it's true for the start. And well, what's causing it? And whether this is a natural phenomenon which has happened millions of times in the past, or whether humans are responsible. So you come to the issue of greenhouse gases. Now, my simple understanding of a greenhouse is that during the day, when the sun's on it, it absorbs the heat. And then at night, the windows close, the roof closes, and the heat is kept in. Now, I don't see any examples of this happening in nature, that something is working during the day and then not working at night in a way that would resemble a greenhouse. But the argument is we have things called greenhouse gases, which trap the heat near the Earth, causing the planet to get warmer. Okay, well, let's look at the logic behind this. So the air is primarily made up of nitrogen and oxygen, and these two together form, I think, 95% of the atmosphere, of air. And neither of these are given the name greenhouse gas, okay? The number 3 is water vapor. Now, I can see water vapor working with the clouds, and my experience is if it's cloudy, it's cooler. If it's clear, there's no clouds, then it's hotter. The sun can get through to the Earth. Now, the greenhouse effect could work with clouds if, for example, it was sunny all day and then it clouded over at night, and that would keep the heat in. And if that happened hundreds and hundreds of days on the trot, then no doubt the planet would get warmer. But we don't have any control over the clouds, and it's not our natural behavior to actually cause the clouds to stay there at night, which would be nice if you lived in that part of the world. So the idea that a gas has this ability, any other gases have this ability to let the heat through during the day and then hold it in at night is beyond me. And the one that is most highlighted is carbon dioxide. And yet carbon dioxide forms less than it's 0.04% of air, of the atmosphere. Now, to me, this is negligible. And the other nitrous oxide or sulfur dioxide and the other so-called poisonous gases are even smaller quantities. And while we can't see them, and so they can let the light through, I really can't believe they work in a sort of one-directional basis, that the fact they let the heat through from above, but they hold it in from below, is like, why would they do that? Do they have the intelligence to selectively control the direction of heat? This just doesn't seem to make sense to me, plus the small amount of it. And carbon dioxide, anyway, is essential for all green things. If somehow we were able to get rid of carbon dioxide, all the green things on the Earth would die, because they take in carbon dioxide during the day and breathe out oxygen, which we need, and we breathe in oxygen and breathe out carbon dioxide. And so the idea that this is somehow bad for the environment is beyond me. And so the example of Venus is used. The planet Venus has an atmosphere, and it's completely covered in clouds all the time, and apparently the ground temperature is 500 degrees centigrade, the hottest place in the solar system. And so the argument is this is runaway greenhouse effect, and this is what would happen on Earth. Yet we don't know the constituents of the gas on Venus, and we certainly don't know what Venus was like before. Maybe it's never had access to the sky. Maybe when it started, it had this gaseous cloud, and it's always been there. And maybe Venus had lots of volcanic eruptions at the beginning, and that's what caused the heat. Who knows? The idea it was the sun that caused the heat, or some predecessor civilization that had runaway global warming because they lost control of the environment, is highly far-fetched, and we have zero evidence to support that. So I'm not convinced by any of those arguments. And the other piece of evidence against global warming is the alleged disappearance of the dinosaurs. Now, they apparently disappeared some 60 million years ago following a meteorite explosion hitting the ground and causing such a dust cloud to go up that the sun was cut out for months and months on end. And as a result, so the scientists claim, the temperature collapsed, plant life died, all the plant eaters died, and then ultimately the meat eaters had no meat to eat and they died out. Well, that's the opposite of what the scientists are saying about global warming. They're saying if all the clouds keep the heat in, then the temperature will go up and we'll have runaway global warming. But that's not what happened to the dinosaurs. It's quite the opposite. And logically to me, as I said before, when it's cloudy, it's cooler. Certainly during the day, maybe not so at night, but it's still cold. If it's cloudy, the sun is blocked. If you block the sun, where is the heat going to come from to warm the land in order to cause the greenhouse effect? So I really can't see that this would happen. I'm not convinced. And similarly with sea level rising, I'm not convinced that water works in the way that the scientists are saying. So let's have a look at ice. Well, first of all, ice is 90% of the density of water at 0 degrees. As you know, when you fill a cup of ice and it melts, the water level is only 90% of the cup. And that's because ice is less dense than water. Ice floats on water with 10% sticking out and 90% under the water, as the unsinkable Titanic discovered when it hit an underwater iceberg 100 years ago. So when ice melts, what happens? Well, sea level goes down, not up, because the water will occupy less space than the iceberg that it was displacing. So maybe. So if all the ice on the Arctic melts, I would expect sea levels to go down, not up, because the Arctic is an ocean, there's no land. Okay, so they say Greenland has got a big ice sheet, Antarctica has got lots of ice, so all the water runs off there when it melts into the sea. Okay, that may well put up sea levels around the world. But what happens when the water gets warmer? Well, between 0 and 4 degrees, water gets denser, gets heavier, it shrinks and it sinks to the bottom. So if the sea temperature of the melted ice increases from 0 to 4, sea level will go down, not up. After 4 degrees, yes, it will start rising, but this is not the only phenomenon at play. Now remember, the bottom of the sea is 4 degrees, and so only the top bit of the sea can change temperature. That's exposed to the air. So if the air temperature goes up, only the top bit of water will increase in temperature. What happens if you warm up water? It evaporates. The warmer the temperature, the faster the evaporation. So what happens to the water vapor? It forms clouds. They then reduce the temperature by blocking the sunlight, and also they cause rain. And so the rain will come down, and so you get the water cycle. Now, warmer air supports more water vapor than cold air, as we see with condensation. If there's a cold area and you breathe out, you can produce steam. The water condenses on cold area. But as the air warms up, the so-called dew point, the point at which condensation occurs, goes up. And so the higher the temperature of the air, the more water vapor it can support. So it's not clear to me that simply warming up seawater will cause any kind of sea level rise. It will cause more evaporation. Yes, it may well cause more rain in the short term, maybe, but it could well be an equilibrium. You know, the Earth has been here for maybe millions of years, and it's been through temperature changes before, and we're still here. And life forms are still here, so it hasn't wiped out all life forms. It may well be there'll be some problems living on the coast if there is some small temperature rise causing some kind of sea level rise, and people may have to move, and that may well cause problems because of borders. People can't necessarily move to the safest part of the planet because they need a visa, basically. But the fundamental science behind it, to me, is not convincing. I'm not convinced. And because I doubt scientists over the Big Bang, and I doubt scientists over evolution, I have to say I also doubt them over climate change. Come on, scientists, prove it to me. Give me some real hard evidence that what you're saying actually is a repeatable phenomenon which you can do in the lab to prove your hypothesis or come up with a better hypothesis, please. Thank you for watching.